Every planet in our solar system plays by the same rules. Get too small and your core goes cold. Get too close to the sun and your atmosphere burns away. Get too old and your magnetic field collapses. And with it, any chance you ever had. Mars followed the rules. Venus followed the rules. Even Earth is following them, slowly in ways we don't like to talk about. But Mercury, Mercury is the smallest planet we have. Closest to the Sun. 4 billion years old. Battered beyond recognition by 4 billion years of bombardment. By every rule we know. Its magnetic field should have died before the dinosaurs existed. Before the oceans formed. Before the first single-celled thing pulled itself together in the dark. It didn't. We flew a spacecraft past Mercury in 1974. It found a magnetic field. Not a fossil, not a memory, a living, active field. Pointing into space right now. We have spent 50 years trying to explain it. We cannot. Start with something you already understand. Your compass points north because the Earth's core is moving. Liquid iron, roughly the size of Mars, churning slowly in the dark 3,000 miles beneath your feet. That motion generates electrical currents. Those currents generate a magnetic field. The field reaches 60,000 kilometers into space and deflects the solar wind. The constant stream of charged particles the sun is trying to strip your atmosphere with. We call this a dynamo. Without it, you are Mars. Your atmosphere bleeds away. Your surface turns to radiation-scorched dust. Nothing survives. The dynamo only works while the core stays liquid. The core stays liquid while the planet stays warm. Planets stay warm from the heat left over after they formed. Residual energy from billions of tons of rock smashing together at speed. That heat leaks out slowly. Eventually it runs out. For a large planet, this takes billions of years. For a small one, it happens fast. Mercury is the smallest planet in the solar system. Its diameter is barely larger than the continental United States. Its core should have frozen hundreds of millions of years before complex life appeared on Earth. Every model agrees on this. Every simulation. Every calculation done in the last 50 years. In 1974, Mariner 10 swung past Mercury at over 40 kilometers per second. Its instruments picked up something they were not expecting. A magnetic field. 1% of Earth's strength. Weak, strange, asymmetric, but real. The lead scientist on the magnetometer team later said the result took him completely by surprise. He assumed it was an instrument error. They checked, then they checked again. It wasn't. The field was real, the models were wrong, and nobody knew why. The scientific community spent the next 4 decades building explanations. None of them held. The first theory: Mercury still has a thin outer shell of liquid iron wrapped around its solid inner core. Not enough to sustain a full dynamo. The pressure and temperature are too low, but enough to generate a faint one. A guttering candle instead of a furnace. The problem: for that shell to still be liquid after 4 billion years, something would need to be keeping it warm. We have no mechanism. The numbers say it should have frozen over 1 billion years ago. The second theory: thermoelectric effects at the boundary between the core and the mantle. Heat flowing across that boundary at different rates, generating tiny electrical currents. Currents generating a field too faint to measure from Earth, but detectable up close. The problem: when you run the physics, the field this process could generate is hundreds of times weaker than what Mariner measured. The math doesn't reach, not even close. The third theory: there is no active dynamo at all. What we're detecting is a fossil. Ancient magnetism locked into the crust billions of years ago, back when the planet was young and hot and the dynamo was running at full strength. A ghost field. The echo of something that died long ago. The problem: fossil fields don't behave like this. They're local, patchy. They don't extend cleanly and coherently into space the way Mercury's does. In 2011, after 37 years of uncertainty, NASA placed a spacecraft called Messenger into orbit around Mercury. It was the first mission ever to do so. It spent 4 years mapping the magnetic field at a resolution Mariner could never have achieved. In 2015, the data came back. The field is significantly stronger in Mercury's northern hemisphere than its southern. Not slightly stronger, not within the margin of measurement error. Dramatically, structurally stronger. In a way that no standard dynamo model predicts and no fossil field model explains. We know what Earth's dynamo produces. We know what Mars's dead crust produces. We know what every category of planetary magnetic field looks like. Mercury's field does not match any of them. We built every model we had. The planet ignored all of them. It is still doing something we do not have a name for. By January 2015, the Messenger team knew their time was running out. The spacecraft had been in orbit for 4 years. It had returned more than 270,000 images. It had mapped 95% of the surface in detail no human eye had ever seen. It had answered questions scientists had carried for decades, and it was almost out of fuel. Almost. There was one thing left in the tanks: helium gas, used to pressurize the propellant system. It was never designed to be burned. It was never supposed to serve as propellant. Using it that way was a last resort that the mission planners had quietly calculated years earlier, knowing this day would come. In January 2015, they used it. It bought 4 more weeks of orbital operations, 4 more weeks of magnetic measurements, 4 more weeks of the data that still hadn't explained what Mercury was doing. On April 30th, 2015, at 3:26 in the afternoon Eastern Time, Messenger hit the surface of Mercury at 3.9 kilometers per second. The impact created a crater approximately 16 meters across. The spacecraft carried a small American flag, a piece of the Wright brothers' plane, and several other symbolic objects that are now buried in the regolith of a planet no human has ever visited. No mission is currently scheduled to return. The magnetic data from those final 4 weeks was analyzed for years. It confirmed everything Messenger had found. It deepened every question. It answered nothing. We burned the last fuel to ask one more question. The planet did not answer. Mercury's magnetic field is 1% of Earth's. Earth's magnetic field has weakened by 9% in the last 150 years. Satellites have detected patches in the South Atlantic where the field is already dangerously thin. Thin enough that satellites passing over them receive elevated radiation. Thin enough that ground-level exposure is measurably higher. The patch is growing. Scientists call it the South Atlantic Anomaly. They say it is not unusual on geological timescales. They say Earth's field has reversed hundreds of times in the past, and the planet survived each one. They do not mention Mercury very often in these conversations. A field that is weakening on a timeline no model predicted. A core behaving in ways that don't match the theory. A mechanism we assumed we understood, and don't. We study Mercury because it is small and strange and 57 million miles away. We should study it because it is the only planet in the solar system doing something our best physics cannot explain, and because one of the things we cannot explain about it looks uncomfortably familiar. Mercury is not a warning from another world. It is a mirror. We just haven't decided to look at it yet.